All right, let's go ahead and get started with our exponential quiz review homework help video. Now, I'm going to make it very clear which types of problems you are most likely to see on the quiz in this video. This quiz review includes problems that are above the level that you're going to see in the quiz tomorrow. No problem will require logarithms. I'll still do those problems in the video, but we'll get started with the ones that are most relevant. The problem that we could definitely see would be a problem like number 1. Ashley invests $6,204 in a saving account with a fixed annual interest rate of 5%, compounded 3 times per year. As I'm reading, I'm probably underlining the important numbers. What will the account balance be after 7 years? All right, I start listing off the values I've been given and the variables that they represent. That 6,204 is my principal. That 5% is my rate, so I'm going to write that as a decimal. 5% becomes 0.05. 3 times per year is my n value, and 7 years is my t value. Next, I'm going to grab my compound interest formula, which is on your green sheet that you're allowed to bring to the quiz. The final amount A is equal to P times quantity 1 plus R over N to the NT. I'm going to fill in the values that I have. 6,204 equals 1 plus 0.05 over 3, all to the power of 3 times t is 7. Now, I could simplify this down here. You know, an easy thing to simplify would be make this a 21. But honestly, to avoid mistakes, I should do the simplification steps, but then use my calculator to do the rest. So let's plug this in. We got 6,204 times 1 plus 0.05 divided by 3, all to the power of 21. Final amount, $8,778.54. $8,778.54. And then always check for reasonableness. This number is bigger than what we started with. That's good, but it's not absurdly bigger. It's still in the same order of magnitude. All these things tell me that I probably did this correctly. Number 3. Joe invests a sum of money in a savings account with a fixed annual interest rate of 3% compounded 3 times per year. After 11 years, the balance reaches $8,098.84. So this is now my A value. I've got a final amount. So A is 8,098.84. N is 3. T is 11. And our interest rate is 0.03. Plug these in to our compound interest formula, and we'll get $8,098.84 equals our unknown initial amount times 1 plus the rate divided by the compounding periods, all to the power of compounding periods times the number of years. All right, this piece here, everything after the P, can be simplified down to a single number. I'm going to do that in my calculator now. That's 1.01 to the power of 33, or 1.3886 equals 8,098.84. I'm just going to save this number in my calculator so that I can preserve precision here. Divide both sides by that number, and we'll get that our principal is equal to press second answer. $5,832 if we round to the nearest cent. We get this 0.00. All right, let's double check that one. 5832 for number 3. 5832. All right, so those are the types of interest problems you're likely to see where we're solving for either final amount or initial amount. I'll double back and do some of these other ones where we're solving for time, where we're solving for interest rate, and where we're solving for, well, this one's time again, but with continuous interest. We'll talk about that one. Another thing that will be on the quiz, though, is this graphing, very similar to this, where we've got a vertical shift, we've got an A value, and we'll either have exponential growth or decay as determined by our B value. So that's our A, that's our K, that's our B value. The very first thing I want to add to my diagram is my horizontal asymptote. The horizontal asymptote is always located at y equals k, and k in this problem is 2, so y equals 2 is our horizontal asymptote, and that gets a dotted line. It's not part of the graph, but it helps us to graph, so we add it in as a dotted line. All right, so there's our horizontal line, y equals 2. This can be thought of as the table that Alice is standing on top of. The A value could be thought of as Alice's height. She is 2 feet tall, so she's 2 feet tall standing on top of a table. That brings her up to 4. And this 1/2 means that she's drinking a beverage that will shrink her to 1/2 her height for each ounce that she drinks. So she was 2 feet above the table. Now she's 1 feet above the table. Half, quarter, eighth, 16th, 32nd, 64th, and we are approaching our horizontal asymptote on this side. All right, so it flattens out to that horizontal asymptote, getting closer and closer. Now, in the opposite direction, if she was getting half as tall, her height will double if we enter a negative amount. So she was 2 feet tall, now she's 4. Next, she'll be 8, again above the table that she's standing on. That brings us to 10. 8 doubled is 16. Add that to the table, we're up to 18. Now we're off the graph. So this diverges to infinity. Good vocab word to know when talking about exponential growth and decay is diverge, the opposite of converge. And there's our graph. Draw and label the horizontal asymptote. That is, I guess we could be more explicit. This is the horizontal asymptote. All right, so graphing, and if we're having difficulty figuring out where the points are, you could always plug this into your calculator and look at the table. Press second graph to see that. All right, now converting exponential to logarithmic form. This is another thing that'll definitely be on the quiz. Here we've got logarithmic form. We have to go back. So I could do the swoop to help me do it in the right order. This is going to be 121 to the power of negative 1/2 equals 1/11. And that's in exponential form now. We can double check with the swoop that it is what we wrote down. 121 to the negative 1/2 equals 1/11. This could be simplified further. Let me see if my answer key simplifies this further. No, it just leaves it like that. So just leave it in that form. Let me show that simplified further. This would be the same as 1/. the square root of 121 equals 1 over 11, and then we see why they are equivalent. But when we want exponential form, that's what we're after. That's exponential form. It has an exponent still. Over here, this one is 8 squared equals 64. It's nice when they're just numbers because then we can double check that that's a true statement. 11 squared is 121. 2 squared is 4. And just rearranging the 3 parts of the logarithms into an exponent. When I go the opposite direction, it's that same rearrangement. One thing I say to help me do this correctly is I say the base of the exponent becomes the base of the log. Then that number on the other side comes over, and our exponent should be on the other side. But you can check this with the swoop by looking at your original equation and seeing, does my original equation read 12 to the 0 equals 1? Let's try this one. Base of the log, or base of the exponent becomes the base of the log. Number on the other side becomes our argument, and it's all equal to the exponent. Few more. Log base 15 of 225 equals 2. Log base 12 of 144 equals 2. Notice the logarithm asks the question 12 to the power of what equals 144. And then on the other side is our answer. 12 to the power of 2 equals 144. All right, so that's up to this point in the video. That's all that you'll need for the quiz tomorrow. A little bit of graphing, some interest problems where we're solving for the initial amount and the final amount, and rearranging into logarithmic form. Now, these other skills, still very useful, but don't expect to be tested on them until the test, which is, I believe, on the 26th. We could check the calendar. Let's make sure that's true. Not this window. The test is on, that was the Unit 5 test. There's our quiz. The 26th, yep. 4-day weekend coming up for you guys with President's Day off. Hopefully you're using this calendar to help you study. All right, now back to these. Condensing, actually, let's jump back to those interest problems. I'll do one of each type. So, let's see, we've done one of those. Okay. $3,348 in a retirement account, 6% compounded 2 times per year. How long will it take for the account balance to reach 9,146.42? So I set this up, filling in the values where they go in my compound interest formula, making sure to express my percent as a decimal, but then leaving t as a variable. We're going to have to solve for t. I'll divide both sides by this 3,348. I'll get 9,146, 9,146.42 divided by 3,348. 2.73 equals 1.03 to the 2t. At this point here, to continue solving, we need to rearrange this into a logarithm. So the base of the exponent becomes the base of the log. The number over here, the number across, becomes our argument. And the exponent is on the other side of the equal sign. This has a value. Now, if we have an older calculator, we have to use a change of base formula to solve for it. If we have a newer calculator, we can just plug this in. But if you need to use the change of base formula, this is equal to log base 10 of 2.73 divided by log base 10 of 1.03. And then I'll show how to plug that into the calculator to t. Let's get our calculator out again. Log 2.73 divided by the log 1.03. All right, this side of the equation should be 33 point, well, it should be about 34. Let's divide that by 2 to get that our final amount of time is 16.98. So this became about 34 equals 2t, which then becomes 16 equals t. And I think we want to round that up to 16 because if it's compounded 2 times per year, at 15 and a half years, we have definitely not reached that. It's only when it compounds on the beginning of the 16th year that we get the full amount. All right, so 16, let's add a unit to that before I go away, 16 years. All right, Amanda invests $2,224 in a savings account. So that's my principal, $2,224. Compounded 4 times per year. We don't know R, but we do know that it is compounded for 12 years. This equals 6,471.04. First thing I'll do is I'll combine this into a 48. And I'm going to divide both sides by that 2,224. All right, and I get a number over here that's about 2.9, but keep it in your calculator, equals 1 plus r over 4, all to the power of 48. How do I get rid of an exponent? Well, don't start thinking logarithms again. What we actually want to think is back to our unit of radicals. Let's raise this both sides to the power of 1 over 48. We're effectively taking the 48th root of both sides. On this side here, 2.9 to the power, and keep that 1 over 48 instead of parentheses. We get 1.0224 equals 1 plus the rate over 4. Subtract 1 from both sides, multiply both sides by 4. And we get just under 9%. I'm going to guess that I just want to round that up to 0.09 or 9%. Yeah, I got 0.0897. I'm assuming that 9% is what they're actually going for here. Let's see our answer number 7. 9%, yeah. So I'll just round that. Okay. So yeah, the real trick was the raising to the power of 1 over 48, and we know that when we raise an exponent to an exponent, we can multiply those, and on this side, they'll cancel out. On this side, we just get a number. All right. Number 9. Let's see, we've got 3,059 in a savings account. Oh, compounded continuously, so I don't need any parentheses here. I need an e to the RT. The rate is 0.09. The time is 6. So our final balance A can be calculated by just plugging that whole thing into our calculator. 3,059. You can do second ln to get an e to the power of 0.09 times 6. And I get A equals 5,249 and 26 cents. Our formula there, this came from PERT, PE to the RT. And that whole thing can just be plugged into your calculator. Let me just show that. I won't show the whole thing, but the E button on your calculator is either second ln, if you want to get an E to the power of. If you want an E by itself, it's second divide. All right. I think this will be our last problem for today. Yeah. Okay. Well, wait, we have those condensing problems. Never mind. Okay. Carlos invests How much does he invest? $7,176 in a retirement account. Compounded continuously, so we're using PERT. So 7,176 times e to the power of 0.09 for our interest rate times unknown time t. We want to figure out when this equals this number here. So we got to divide both sides by 7,176. And if I take 25,298.42, divide it by 7176, I get a number that I'm going to leave in my calculator, but it's about 3.53. All right, now I got to rearrange this into a logarithm. So it's going to be log base e of 3.53 equals 0.09 times t. Now the shortcut here, I don't have to write log base e. We use log base e so much that it gets its own abbreviation. It is ln, the natural log. So ln 3.53 equals 0.09 t. All right, and let me show you how to do that. So I don't need to press second, I just need ln of 3.5, I guess it was 254208447, but you should just be using second answer to be getting the most precise answer possible. And we'll want to take that and divide it by 0.09 to get that we should wait 14 years. T equals 14 years. So yeah, log base e is ln. I'll write that down. Log base e equals ln. Same thing. All right, we have these problems at the end. Condensing and expanding. And this problem, number 23, uses the natural log. All of our properties of logarithms are going to be the same, though. It's just log base e, but the base of the log doesn't matter. We can still do things like taking that 4 and making it the exponent on c. I want to take that divide by 2, make it, and instead of multiplying by 1/2, this here is going to become ln a to the 1/2. And we can maybe leave it like that, but I think I'd rather do ln of the square root of a. These things are being added, so that means I can multiply what's inside. This eventually becomes the natural log of the square root of a times c to the 4th. All right, with these divide by 3s, those can become cubed roots. This one here becomes log base 3 of the cubed root of 70. Because once I am adding them and then multiplying them, all those cubed roots can combine. Think back to our unit on radicals. Expanding these, we're going to use our properties the other direction. I can bring that 4 in front, so make this 4 log base 5 of 8 cubed over 3. And just leave it as 8 cubed. Don't simplify that. Now this can become 4 log base 5 of 8 cubed minus 4 log base 5 of 3. That's because the division here, we can split it into 2 logarithms that are being subtracted. This 3 can multiply there to get our final answer, 12 log base 5 of 8 minus 4 log base 5 of 3. Let me check that one. 12 log base 5, 8, 4 log base 5, 3. All right, more condensing, expanding to come before the test. We'll definitely keep practicing that. Hopefully those 4 problems, though, will be good practice so that We'll have to cover less bases before the test. Hopefully it's been useful, and I will see you tomorrow for the quiz, most likely, unless you're watching this some other time.